one of the important things is, I mean, to me, it's important, is exactly what are quasars, what this new discovery is, and kind of what does it mean? Does it really mean anything? Like the beginning of the universe is somehow different in some way or another, or is it really just kind of just an interesting, somewhat interesting story? We will find that out as I adjust my camera so I'm not in the view right here. So this is from earth.com, as I said. Let us transport ourselves back in time to an era when the universe was a mere 900 million years old, a period known as the Cosmic Dawn. Amidst this evolution of our universe, astronomers have made an extraordinary discovery, a pair of merging quasars, each powered by a supermassive black hole, locked in a gravitational dance of immense scale and energy. This observation observes a rare glimpse into the dynamic processes that shape the early universes or the early universe and its structures. Okay, so what are quasars exactly? Quasars are exceedingly luminous astronomical objects that often outshine entire galaxy. This immense energy output is generated by a supermassive black hole residing at the core of the quasar. These black holes, millions or even billions of times more massive than our sun, exert a gravitational pull so powerful that it draws in surrounding matter. As this matter spirals towards the black hole, it forms an accretion disk, a swirling vortex of gas and dust. Within this disk, intense frictional and gravitational forces generate extreme temperatures, causing the matter to emit vast amounts of radiation across the electromagnetic spectrum. This radiant energy is what makes quasars some of the brightest objects in the observable universe. The study of quasars provides valuable insights into the evolutions of galaxies, blah, blah, blah. Okay. So these things are, like it said, supermassive black holes. And now supermassive black holes are, like it said, billions of times more mass. So they have more mass. So they're heavier and larger than our own sun. So these things are extremely large. Luckily, we're talking about here looking at something that is billions and billions of light years away from us, which is a good thing. But the discovery of this is actually two in the middle. And so, kind of, what is the importance of this in regards to the early universe? So, we'll actually take a look at Yoshiki Matsuoka, an astronomer from Ehime University in Japan. While meticulously examining images captured by the Hyper Supreme Cam on the Subaru telescope, they notice a curious pair of red dots nestly close together. So what are these things? Big red dots very close within each other in this image that they're taking. Matsuoka remarked, the discovery was purely serendipitous. Unaware of the remarkable implications this chance observation held. And you can see right here, we're actually going to go to their website and see some other images of this as well. They did a really good job with this, got some really cool images. And we'll also talk about the technology that was used to generate these images. They actually used a camera to snap these photos. And it's not just a regular iPhone camera. Upon closer inspection, these red dots were revealed to be quasars, each harboring a colossal black hole exceeding 100 million solar masses. Pretty big. Astoundingly, these quasars were separated by a mere 10,000 light years, a distance comparable to the width of our Milky Way galaxy. Wow. So pretty close together and super, super massive. This close proximity was no mere coincidence, but a telltale sign of a cataclysmic merger in process. The host galaxies of these quasars were locked in a gravitational embrace, their supermassive black holes spiraling towards an inevitable collision. This merger will ultimately give birth to a single event, even more monstrous black hole, forever altering the cosmic landscape. So when they come together, it's going to be pretty large. But once again, we're talking something that is billions and billions of light years away. However, it's maybe possible that that event has already happened. We just have not seen it yet. So maybe the black holes currently at this very moment in June 19th, 20th, whatever it is of 2024, maybe those black holes have already merged and this massive, massive event has already happened. We still obviously have not seen any real effects of it because our solar system isn't all of a sudden getting sucked into this monstrous black hole. It doesn't work like that. But we have to wait until either we can detect some sort of gravitational wave, some other types of frequencies that are coming from this specific event, until we get actual X-ray or some kind of gamma rays or different types of rays, such as visible light as well, infrared. Wait for these to come before we can actually see it, because those unfortunately travel at the speed of light. And like I said, it is 12, 13 billion light years away. So the light from there to here on Earth takes 12 to 13 billion years. So it's a very, very long time scale, and especially very, very high variance of where we kind of come in. I mean, I'm 26. 26 years when we're talking about 12 to 13 billion years is a very, very small percentage of that time. So it would be very unlikely that I or probably anybody within my entire family tree going back to the first people probably has not seen it. And the event probably didn't happen within their lifetime. So we're talking a very long time scale here. So just keep that in mind. And then we'll go, yeah. Got some more quotes right here. The Gemini near-infrared spectrograph on Gemini North played a crucial role in confirming the identity of these merging quasars and uncovering the secrets of their host galaxies. Quote, what we learned from the GNIRS observations was that the quasars are too faint to detect in near-infrared even with one of the largest telescopes on the ground. This faintness indicated that a portion of the observed light originated not from the quasars themselves, but from the intense star formation occurring within their merging galaxies. Interesting. Furthermore, the GNIRS observations detect a bridge of gas connecting the two quasars, providing compelling evidence to their impending merger. Amazing. This monumental discovery offers a rare glimpse into the period of the universe that has long remained elusive. By studying these distant objects, astronomers can unlock valuable insights into the processes that shaped the early universe and laid the foundation for the magnificent cosmic structures we marvel at today. The discovery of this emerging quasar pair marks a significant milestone in our understanding of the cosmos. As astronomers venture deeper into the universe's mysteries, they anticipate uncovering more of these enigmatic objects, gradually piecing together the intricate puzzle of the early universe's evolution. So let's go further in and kind of discover what this stuff is. So this is the NAOG, as you can see. This is their website. As always, I will put their stuff all down in the description. No need to worry about, but this is the camera that I was talking about to you. This is a, as they say, gigantic digital camera for this Subaru telescope, right? Now, this Subaru telescope, you would have to imagine is pretty big, but let's take a look at the image right here. I mean, that's a person that's 158 centimeters tall. So you'd have to imagine that they are pretty large, or approximately about 5'2". See all the different things right here. The inside of it, top frame, instrument, blah, blah, blah. bunch of motors, bunch of different things within it. So very cool. Let's go back. The Hyper Supreme Cam is a gigantic digital camera for the 8.2 meter Subaru telescope, which was developed by National Astronomical Observatory of Japan in collaboration with international academic and industrial partners. Because the telescope is large, its camera is also large. The height is taller than a human being, and its weight is about 3 tons. Very, 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 very heavy. The camera consists of lens, filter, shutters, and light sensors. The sensor is newly developed, highly sensitive CCD, and the pixel number is 870 megapixels, and a total that cover 1.5 degree field of view in diameter. These CCDs are installed inside a vacuum cryogenic dewar, and I don't know what that means, and are operated at minus 100 degrees Celsius, where the dark current becomes negligible, which is oftentimes why a lot of the satellites that take pictures and scans of deep parts of the universe, such as the James Webb Space Telescope, do it very, very far in space because it is very, very cold unless you're in the sunlight. But you can also mitigate that by what the James Webb Space Telescope does is whatever is facing the sun is a bunch of things to cool down the device so that the camera's on the opposite side after there's many different layers of shielding from the sun. That camera gets to be cold. So very, very common to just throw this thing up in space, but it is nice to be able to have it here on. The diameter of the first lens is 82 centimeters, and the length of the lens barrels is 165 centimeters. So certainly taller than 5'2". Mechanical alignment of optics, or in other words, focus adjustment, is realized by the precision hexapod system that consists of 6 customized actuators. So this camera saw the first light in 2013 and started to serve for open use observations from 2014 as a facility instrument. Very, very cool. So that's what this camera that took this picture looks like. So very large things we're talking about. But this is Subaru telescope telling its science results on this little thing right here. And I wanted to just play this video before we get into it, and I'll narrate over this. This is kind of a brief overview. We'll go through this video. Then after the video, we'll go through the story. Astronomers have discovered the most distant pair of merging quasars ever known. In only 900 years. The discovery was made with the Gemini North Telescope and the Subaru Telescope in Mauna Kea. This pair of quasars is found in a distant era of the universe's history known as the epoch, very early within the existence of our universe. During this time, the earliest stars, galaxies, and quasars were forming and filling the universe with light for the very first time. This is the only pair of quasars ever found in the organization, giving astronomers valuable insights into the formation of the universe's earliest structures. These things actually existed at this time. So it's giving you a sliver of hope that during this time, or not even of hope, but a sliver of factual information about this particular time when it was believed previously. I mean, we can go back to the video. The early formation of the universe and how it came about is one of the most important questions within astronomy, and I would say probably physics as well. And I think it's something that a lot of us I mean, myself included, a lot of us question, how did everything start? What started the universe? Was it the Big Bang? Was it some creature? Was it some heavenly body being creating it? What started this whole thing off? Is there a creator of the universe? This is stuff that I assume many of us have been questioning our entire lives. And for a lot of us, we find meaning in a lot of different areas. And how you choose to answer this question is something that does not stay the same forever. It's something that oftentimes will switch. You don't have the same answer today on where did we come from at 26 that you do at age 12 or age 16 or age 20. It is a question that for many of my friends, many of my family members, is something that is very subconsciously a major role in all of our daily choices. Trying to answer this constant question of where we come from, why are we here, and what is all of this for? What is this life for? What is my purpose? That's something that every one of us ask. And these quasars being at the beginning of our universe helps shape that future for us, because whether there's one more or one less quasar, that could have a significant effect on how our own solar system was formed, how our own galaxy was formed, how our local galaxy group was formed, how our entire universe was formed was dictated by this very early stage of our universe, because closer to the beginning of it, it was a lot smaller. So things were a lot closer together, which is why you could see these quasars that were basically a Milky Way galaxy apart from each other. And they were they were, if not hundreds of millions of times more massive than our own sun. If there's a couple of these during an early period of our universe when it's much smaller, that creates a whole lot of different outcomes later on. Just fascinating. But we'll get into what they actually talked about. Using the Subaru telescope and Gemini North telescope, both located on Mauna Kea and Hawaii, an international team of astronomers has found the earliest pair of quasars, monsters shining with intense radiation powered by actively feeding supermassive black holes. This discovery will help explain how the universe evolved. So let's take a look right here. So you can see, I guess is the correct term. You can see right over here, right where my mouse is, this is C1. So you can see that super, super red spot right there. That's a very one thing, the reason why that is so red as it is, whereas if you take, say, a look over here and look at something like this, you can definitely tell this is some type of galaxy right here. That's not as red. Or even if you go within this picture, you can see right up here, that's kind of bluish. Down there, that's kind of bluish. But that is a bright, bright, dark red. Very dark red. And oftentimes what this is something called redshifting. So when an object such as quasars is billions and billions and billions of light years away, what happens is as that light is on its journey to our eyes and our instruments and our planet, our solar system, while it's on its journey there, the universe has expanded. The same effect happens when you have an ambulance driving towards you with its sirens on. You kind of get a higher tone as it's coming towards you, and then as it passes by you, it gets a lower tone. A similar effect happens where you have the light coming towards us and the universe is expanding at that very same time as well. So that light is getting red shifted. So say if it's a blue, it gets a little bit closer to the red side. If you look at an electromagnetic spectrum of visible light, you can see that something that's blue, and take away some of that energy from it, it starts to go towards the red side of that spectrum, which is the red light that we see. So you can see right here at C1 and C2 is something I'll talk about in a second. This C1 is very clearly visible. Very clearly a bright, dark red spot. I know that's kind of weird to say, but it's a red spot that's very dark, but it's very pronounced in this image. I mean, we're talking about something very, very far away. And then right here, I'm able to see this on my screen right here. This right here is C2. I'm trying to do my best to outline it. Hopefully, if you turn your brightness up, you can see what I'm outlining right there. I can't go much further down. Darn. Yeah, but it's right here, basically. That is C2. So that's the other quasar. Obviously, you can see that it's not as bright, but the other quasar that is moving towards the other one. Maybe that's because C1 is a quasar that has taken a lot of the matter from the C2 quasar. But very, very interesting stuff right here. But let's continue reading. About 400 million to 1 billion years after the Big Bang, something, possibly a combination of sources, unleashed enough radiation to strip the electrons from most of the hydrogen atoms, completely altering the nature of the universe. Quasars are one potential source of the radiation that caused this reionization of the universe. When matter falls into the supermassive black hole at the center of a galaxy, the matter heats up and releases radiation in a phenomenon known as a quasar. So as it's getting sucked in, it releases that radiation. The collision and merger of two galaxies can feed matter to the supermassive black holes, triggering quasar activity. So at a time when intense radiation was baking the entire universe, you would expect to see many twin quasars, as quasar activity fired up in both galaxies involved in a collision. But the approximately 300 quasars known of this era of reionization, there were 0 pairs. Interesting. That's the important point. Then Yoshiki Matsuyoko at Ehime University in Japan was looking over images taken by the Subaru telescope and noticed a faint patch of red. While screening images of quasar candidates, I noticed 2 similarly and extremely red sources next to each other. The discovery was purely serendipitous, as we heard his quote earlier. Follow-up observations with the Subaru telescope and Gemini North telescope confirm that the red spots are indeed twin quasars that existed only, as we know, 900 million years after the Big Bang. Very, very cool. And I think, to go back to an earlier point, the idea that there were certain events and certain things that happened in the earlier universe that we were not able to predict. And that's the current state of astronomical science, where we don't exactly know 100% when the Big Bang happened. We're not even entirely 100% certain that the Big Bang is 100% fact. There is overwhelming evidence. There's lots of evidence, and I've talked about on this podcast before, for the Big Bang. Look up something called the cosmic microwave background. Cosmic microwave background. And also look at Higgs boson as well for more information. Very cool stuff. Lots of evidence for it. But I think one of the things that a lot of people in this day and age are either thinking about or even missing is asking this question of where we are from. And how did this all start? Who started it? Was it on purpose? Was it just an act of nature? Because we can conceptualize and we can imagine that this experience that we're having, and where we can see things that are billions and billions of light years away provides evidence that these things that long ago somewhere out in the universe. We know that because of these quasars, that the universe is at least 12 billion light years old, 12 billion years old. Say we find something that's 20 billion light years away, then we change it right there. So it's an ever evolving, ever kind of getting new evidence, new updates to it kind of question. And I think a lot of us would be very, very, very informed on what we should do with our lives if we ask this question of ourselves seriously more often, because I think it's a serious thing to consider, because there are many people who kind of just go through their life and they never deal with this question. They never deal with their own mortality. They're so focused on their jobs. They're so focused on their lives. They're so focused on their kids. They're so focused on their hobbies. They're so focused on everything else that they shouldn't be worried about within their life. And yes, kids are important. Yes, your job is important. Your hobbies are important. Going to the gym is important. Going to church is important if it is to you. Finding something to do if it's important to you. Recording a podcast if it's important to you. There are things that you can do that can make your life a lot more enjoyable, but I would argue that you're not getting 100%. Trying to think on a regular basis about the origins of how humans got here on Earth and the origins of our universe are incredibly important, because it makes you realize and it makes you contend with the idea of, okay, well, what's going on out there? What am I? What is my life? What does my life mean? What is the importance of my life? How do I want to leave my life? Do I want to leave a legacy of somebody who was focused with their family, focused with trying to help out their community, focused on being a good guy? Is that the legacy that I want to leave behind? Because I think we all realize that there's a very high chance that we only live this thing once. And quasars in the early part of the universe, if there are pairs out there, and this is the first pair that we've seen, maybe there's others, but if there's one more or one fewer, that would have completely changed the outcome of the early universe, which changes the outcome of the next billion upon billion upon billion upon billion of years. And things have fallen into place where they have for this planet to be this close to its parent sun with these other planets that are around it. I've talked many times about Jupiter, how important Jupiter was for the early universe. One of the major roles of Jupiter in the early universe was to protect the inner planets such as Mars, Earth, Venus, Mercury from getting hit with things like asteroids, things from way, way far out, past Saturn, past Neptune, past all of those places. It was a massive planet, and the reason why it has so many moons now is because a lot of things in the earlier universe, in the early solar system especially, were coming right at it, and before they could get close to the inner planets, they encountered Jupiter, and Jupiter is the most massive planet in our solar system, and it acts as a basic garbage disposal. All the bad stuff would be trying to go to the inner planets towards the sun, but on their journey there, they would get swept up in Jupiter. And so a planet like that is extremely, extremely important to the survival of humans. And you don't get a Jupiter in every single planetary star system that's out there. And you don't get a place like Mars. You don't get a place like Earth. You don't get a place like Venus. You don't get these unique places that just happen to be in this part of the universe, this part of the galaxy, this part of our local solar system. This little planet Earth, where life somehow or another doesn't Doesn't mean whether or not that there was some greater, higher power force that placed it down here. I'm not saying that's not true. That very well could have happened, but there was a set of circumstances that allowed me to be here and allowed literally every single other person who has ever lived and will ever lived on this planet the opportunity to experience life. And I think it's important to every so often have that in your mind. Know that. That's why I talk about this stuff, because I think it's so important and it gives you such clarity on wanting to be a good person, wanting to help other people out, wanting to say, hey, you know what? Let me tip you an extra couple bucks. Let me give you a ride home from work. Let me go and do this extra work at work, stuff that I'm not being asked to do to try and help you out. You're trying to promote something? Okay, let me cut up a video for you. Oh, perfect. Thank you very much. Absolutely. You know what? I'm also going to create a little graphic for you as well. Yeah, and then there's this thing called ChatGPT. If you type in what you're going to use this for and provide this picture of it as well and ask it to help you come up with a message or an overall theme or a catchphrase or some kind of radio read or television advertisement, help it write that for you. Plug all of this in and get an answer out. See if you like it. And if you do, perfect, use it. But if you don't, maybe it's the start of something. Maybe it's the pillars of something. All of this stuff of trying to go that extra mile of helping other people out, being a positive member of your community and being a good person. A lot of this for me, and I'm not saying I'm 100% a good person. I have infinite flaws, but a lot of the things that I do that are good for people that bring me a lot of joy is the understanding of the fact that we come from something and there was a certain set of events that all went into place how they happened, and that's how I got here. And I'm understanding more about that. And what are quasars? Why do I care about quasars? Well, because they're extremely important and they're super massive black holes. Like these things actually exist and we can see it with our eyeballs. Well, our eyeballs plus a lot of telescopes. But the knowledge of knowing that these things are out there and that our universe kind of started off in this particular way, I think is so important. And it gives a lot of clarity to your life and how you should lead it.